Hi friends, in this video we are going to discuss about how to apply current division rule in the given networks. Okay, so actually the concept of current division rule is what? Whenever the current is divided at the junction point, so to calculate that particular divided currents from the junction point, so we need to find those currents which are flowing in the individual branches. Okay, so just see this example, this network. So in this network, just see, for example, we are assuming this is the node point. For example, we are considering. So at this node point, so I1 is the incoming current, and here I2, I3 are the outgoing currents from this particular junction point. It means the current flowing through R2 and current flowing through R3 are the currents which are divided from the total current which is available at this particular junction point. It means the total current at this junction point now we are calling as I1, because this I1 is coming from this voltage source, and this current is starting from, or simply we can say that the source of this current I1 is voltage source 50 volts. Now this current is directly starting from this positive terminal of voltage source, and it will reaches this node point. After this node point, we have two branches, that is R2 and R3. So these R2, R3 are connected from this junction point. That is the reason why current will also divide in these two branches. So now our target is to find the current flowing through R2, that is I2, and current flowing through R3, that is I3. Now when we are going to finding the value of I2 and I3, so we always used to find these currents with the help of current division rule. The meaning of current division rule is what? Whenever we are going to find the divided currents from this junction point and which are going in individual branches like R2 and R3, so we need to find these two currents, I2 and I3. So this is possible by using the concept of current division rule. And how we are going to apply this current division rule, and what is the formula of this current division rule, and how we are calculating the value of I2 and I3 in this given network. Let's see. Okay, now the main concept is, if you are going to find the value of I2 and I3 by applying current division rule, you will get the value of I2 and I3. That is clear. But if you know about the how much amount of current is available at this particular junction point, then only it is possible to calculate the value of I2 and I3. Because if you don't know about how much amount of current is available at this junction point, if you don't know, then it is not possible to find the value of I2 and I3, because the formula given by current division rule. So in shortcut we are calling as CDR. So we are by applying the current division rule. So the formula given by current division rule is, so this is total current into opposite resistance divided by total resistance. Okay, so here this is the formula given by current division rule. Here what we are doing, the meaning of total current. So instead of this total current, which value we are going to take? We always substitute the value of total current, that is how much amount of current is available at this junction point. So that is the total current when we are going to finding the value of I2 and I3. So here, while calculating the value of I2, the total current available at this particular junction point is what? So total current into opposite resistance, means if you are finding the value of current I2 which is flowing through R2, means the opposite resistance is always R3, and divided by total resistance means addition of R2 and R3. Sir, why we are taking only R2 and R3? Why we are not considering this R1 in this problem while we are applying current division? Means, so we need to consider the value of resistances. We need to consider the value of resistances only R2 and R3, because the current is dividing in R2 and R3, not in R1, because the I1 which is flowing through R1 is total current in the network. Okay, but I2 and I3 are the current which are divided from this junction point of current. Yes or no? So that is the reason why in R2 branch and R3 branch current is dividing. That is the reason why only we are considering these two values. Clear? Now see here. So if you are going to find the value of total current, for example, actually by applying current division rule, this formula we can find the value of I2 and I3. But before we are going to finding the value of I2 and I3, first we need to calculate how much amount of current available at this particular junction point. So that particular current is given by the total current which is flowing in the network. Okay, so that is the reason why first we need to calculate this particular total current in the network. After knowing the value of total current, then only it is possible to find the value of I2 and I3. Okay, so for that we are going for the calculation of total current in the network. Okay, now see here. So first we are going for the calculation of total current. Now see, again I am redrawing the network here, the C. So this one is R1 is equal to, so 1 ohm. This one R2 is equal to 10 ohms, and this one R3 is equal to 20 ohms, and here we are applying some voltage. So here V is equal to 50 volts. Okay, now first our target is to find what? Our target is to find the value of total current which is flowing in the network, and that total current only available at this point. Yes or no? So that's why what I'm doing, first calculation of total current is required. So total current is IT. IT represents the total current is required. Clear? Now see here. So here, as per Ohm's law, so total current is equal to total applied voltage Vt divided by total value of resistance. Okay, so we know that when two resistances are connected in parallel, how to calculate the equivalent resistance. If two resistances are connected in series, then how to find the equivalent value of the series combination. We know everything. Okay, so if you don't know about how to calculate the equivalent resistance when resistance are connected in parallel and in series, if you don't know, just go through my YouTube channel. So there are so many videos are there. So if you gone through all these videos, you will get full clarity. Okay, now see here. So Vt is the total voltage, that is we are applying 50 volts. The Vt value is 50 volts, but we don't know exactly the value of Rt. So in order to find this particular Rt, so we are going for the calculation of equivalent resistance which is available in the network. Okay, so for that what we are doing, first see here. So R3, R2 both are connected in parallel, because I already told you in the previous videos, in the given network the voltage source is available in the left side, means always we need to start from right side to calculate the equivalent resistance. Okay, so if you are starting from right side, means R2, R3 both are connected in parallel. So when resistances are connected in parallel, how to find? So we know that when the two resistances are connected in parallel, we are going to directly taking, so the product of two resistances, that is R2 into R3 divided by, so addition of resistances, that is R2 plus R3. Clear? Now what I am doing, R1 value, R2 value, R3 value we know, but we don't know the value of what? Equivalent of these two. So that is the reason why what I am doing, I am giving the name for the new resistance is R4. Clear? Now we know the value of R2. R2 is how much? 10. Into R3 is how much? 20. Divided by R2 is how much? 10. Plus R3 is how much? 20. That is equal to, the value of R4 is equal to, so 200 divided by 30. Here 0, 0 cancel, you will get 20 divided by 3. So here the term is, so whenever we are going to calculate the value of total current, we need to first find the total equivalent resistance. So if you are simplifying 20 divided by 3, so it will give the value of R4 as 6.666 ohms. Okay, so this is the value of parallel combination of R2 and R3. Clear? Now what I am doing, I am redrawing this network. Instead of parallel combination of R2, R3, I am placing this R4. Okay, so here just see. Now I'm redrawing this network. So this one is R4, this one is R1, this is the applied voltage. Okay, now see here, after replacing the value of R4, instead of this combination of R2 and R3, now the circuit network becomes like this. Clear? Now find the value of again equivalent resistance. So R1, R4 both are connected in series. Now, so the value of new resistance R5 is equal to, both are connected in series. That's why we are directly add these two values to get the value of new resistance. Now R1 is 1 ohm, R4 is 6.6666 ohms. Now the value of R1 is 1 plus R4 is 6.6666 ohms. Now here R5 is equal to 7.6666 ohms. Clear? Now this R5 we can also call it as what? Total resistance in the system. Clear? So this value is the total resistance. Now you know the value of total resistance. Now substitute this total value of resistance here. Okay. Now see here. The value of total voltage. The value of total voltage is how much? 50 we are applying. Divided by the value of total resistance is how much? 7.6666 ohms. Now if you simplify this value, 50 divided by 7.6666 ohms, you will get the final value as 6.5217. Okay, so this value, so this is not the resistance. So if you are going to simplify this one, you will get 6.5217 amperes. Clear? Now you got the value of current, that is total current is equal to 6.5217 amperes. Okay. Now we got the value of IT. Now this current IT is supplied by what? This particular voltage source. It means here the value of current I1 is flowing and this I1 is flowing and it will reaches this particular junction point. It means at this junction point the total current available is 6.5217 amps. Clear? Now from this point, from this value 6.5217, some amount of current is flowing in R2 resistance, that is I am calling as I2, and some amount of current which is flowing in R3, that is I am calling as I3. Now our target is to find I2 and I3. So in order to find I2 and I3, we are going to apply current division rule. Clear? So now see here how we are applying current division rule and how we are calculating the value of I2 and I3. Clear? Now see here, just see here, very important step here. Now, so we know that the network is like this. So network is like this. So this step is very important. Clear? So this value is R2 is equal to 10 ohms. This value R3 is equal to 20 ohms. And the value of R1 is equal to 1 ohm. And at this point, the current, the value of current available is 6.5217 amps. Clear? Now this one is I1. The applied voltage is 50 volts. Now we need to find the value of I2, the value of I3. Clear? Now here, so by using current division rule, we are calling a shortcut as CDR. Now here, first we are calculating the value of I2. Okay. So current flowing, that is current flowing in R2 branch is equal to, so total current available at this particular junction point into opposite resistance divided by total resistance. So opposite resistance divided by total resistance. Clear? Now see, total, here the total current is the current which is available at the junction point, that is 6.5217 into opposite resistance. Now we are calculating the value of current which is flowing in R2, means the opposite resistance is always R3. Okay, so that is the reason why the value of R3 is equal to how much? 20 ohms divided by the total resistance, means addition of R2 and R3. So addition of R2, R3, it will give the value of what? total resistance. Now substitute all the values here. So 6.5217 into the value of R3 is 20 divided by R1 is 10 plus R3 is again 20. Now here 6.5217 into 20 divided by 30. 0 gets cancelled. Then 6.5217 into 2 divided by 3. If you are going to simplify, or if you are going to calculate the value of this particular 6.5217 into 2 divided by 3, it will gives the value of 4.3478 amps. Okay, so this is the value of current which is flowing in R2 branch. Okay, so it means the value of current which is flowing in R2 is 4.3478. Now what is the pending? Calculation of I3 is required. Now see here, calculation of I3 is again same, but while we are substituting in the current division rule, so here see the calculation of I3 which is flowing in R3 by using current division rule. So total current, again same, total current into opposite, so opposite resistance divided by so total resistance, opposite resistance divided by total resistance. Now we know that the current available at this particular junction point is how much? 6.5217 only. So same from this total current only, the I3 value and current flowing through R3 is dividing. So that is the reason why. So instead of this total current, again we need to substitute 6.5217, that is the total current available at the junction point. Now we are calculating the value of current flowing in R3, means the opposite resistance is always R2 only, because in which branches the current is dividing from the junction point, we need to consider only those particular resistances. That is the reason why we are calculating the value of I3 in R3 resistance, means the opposite resistance is always R2. Clear? Now the value of R2, so here R2 is opposite resistance divided by addition of R2 and R3 will gives the total value of resistance. Now here 6.5217 into the value of R2 is 10 ohms, R3 is 20 ohms. Now substitute these two values. So R2 is 10 divided by R2 10 plus R3 is 20. Now see here, so 6.5217 into 10 divided by 30. So 0 gets cancelled. So 6.5217 divided by 3. So if you are going to find the value of 6.5217 divided by 3, if you are going to simplify, you will get the value of 2.1739 amps. Okay, so this is the value of I3. Clear? Now this is a procedure we need to follow whenever we are going to find the values of currents which are divided from the total current and which are flowing in individual branches of resistances. Then by using current division rule in any network, we are going to get the values of currents like this. Okay, so this is the procedure we need to follow. Anyway, thank you so much for watching, and please do subscribe my channel for more updates. Thank you.